right, so welcome everyone. This is the LMG Lightning Talks. The point of this session is for us to give a number of short presentations. These were all things that we wanted to have on the agenda. They probably could be their own standalone sessions in some cases, or some cases are also just kind of short bits of material that we thought were really important. We wanted to get them out there and go through it and share it with you. So the idea here is for each kind of slot is about 10 minutes. Some may go a little longer, some may go a little shorter. Still, as we go from speaker to speaker, if you've got a question, by all means, raise your hand and we'll get to it. So with that, Sam was first up.
Thanks. Okay. So can we go to the next slide, please?
Okay. Yeah, this does not have.
You don't have any slides.
Oh, okay. So it's on that side.
Yeah. Perfect. Please move to the next slide. Okay, so Android allows us to enable VPN from settings menu. This VPN is called Legacy VPN, referring to the fact that this VPN is provided by Android itself rather than some external Android application. So this legacy VPN feature uses PPTP and L2TP network protocols implemented in kernel. Google added this PPTP and L2TP protocols implementation to Android kernel in those days when mainline kernel was lacking of those protocols. So in Android kernel, PPTP and L2TP protocols are called PPP-OPNS and PPP-OLEC correspondingly, as you can see from this table at the middle of the slide. Later, another implementation of those protocols was added to mainline kernel. So nowadays, Android still relies on its own implementation, while there is already mainline implementation that may be reused. Therefore, Android kernel has both Google and mainline implementation of PPTP-L2TP, which is basically the code duplication. So the actual task is not about upstreaming, like it's stated at the top of the slide, but it's more about hacking Android to use mainline implementation of those features. Please move to the next slide. Okay. So more specifically, we need to make MTPD Android tool to use mainline implementation of L2TP and PPTP protocols. This involves modifying and upstreaming MTPD and PPTPD Android projects. Also, it may occur that some functionality added by Google to Android kernel is missing in mainline kernel. If this is the case, we should upstream this functionality as well. Once this task is done, we can get rid of code duplication, which is quite confusing and can't be maintained properly. So basically, we are going to completely get rid of Android L2TP and PPTP implementation in Android kernel and use mainline implementation. Okay. Okay. For investigating this task, we created a hardware setup, which involves desktop PC, acting as a server, and board with Android on it, acting as a client, connected via Ethernet. MTPD and PPPD Android projects were evoked in order to use mainline kernel L2TP implementation. And also all details on this task are described on the corresponding wiki page, which you can see by opening this link right here. Yeah. Okay, next. So MTPD tool still doesn't play nice with XL2TPD server, so we need to figure out and fix the issue with RON tunnel ID. Also, which was done is PPP-OL2TP plugin is licensed under GPL, which is not acceptable by Android rules, and we probably need to rewrite it at some point. Once L2TP is up and running, we need to prepare the patches and send them to Android, perhaps to the kernel as well for review. And also, we still have the second part of task, which is to do the same work for PPTP implementation. That's it.
All right, and their next speaker is Stuart.
Good afternoon, everyone. Hello? Okay, here we go. So this is not a technical presentation. This is a presentation or talk on the newly formed Linaro Arts team. Does anyone here know what art is? No? Okay. So a while back, ARM invested in a small team to convert Android into 64-bit Android, and we then upstreamed that to Google. And this is kind of following on from that, where having helped Google do their 64-bit port of ART, we're continuing to do some optimizations. Now, we formed in May and have been assigned wholesale into Linaro. I've got a list of the people there, so I think they're all in the room. There's Alex and Sherban and Ninsheng and Scott. And unfortunately, Phil's not here. He's got something more important to do. And what we felt is that a lot of the work that's been done in the past should have been perhaps done in Linaro, given people a chance to contribute. And it really does fall, our mission does fall within Linaro's mission, which is to bring everyone in the industry together in open source, working on key projects of which ART is one. In terms of run times, there is a lot of redundant effort. Each vendor does do their own optimizations, and we do feel that they are very much the same between all of us. And so this effort is to contribute to ART in a way that will benefit everyone. Now, our efforts are split in two. So we've got some called TIP, some called stable. And TIP is where where we are contributing to ART in the Android open source project. The way the team's structured just now, we're working on the AR64 compiler backend. And by doing this, we can help influence ART in such a way that it works well for AR64. An example of that is Alex's, is Alex here? Is Alex Rami's platform-dependent optimizations, where we can do things in a more risk way. There's also another group, well, another effort, which is the stable work. So rather than having members of LMG have to wait for the next release of Android to come out to get optimizations, we're also going to be applying optimizations to released versions. And for this, it will be available to LMG members, so there's so they will be able to get hold of them earlier. You'll see in our engineering reports that we'll be feeding this into the member LCR, so that will contribute to the benchmarks that are reflected there. Just to diagram this a little more closely, my aim for the team is that we will produce somewhat original optimizations, and we'll apply them to the TIP and to stable as best as possible. But as well as that, we're also contributing to the development of ART upstream with Google. One of the things that we realize is we've taken 7 developers, and placed them in Linaro. And this has kind of had a knock-on effect in that we will be dependent on Linaro's infrastructure. So we will be using this for working at the performance of the compiler itself, the size of the code, and also doing unit tests for validation and doing benchmarks and micro-benchmarking. We've got a thing going on in the LMG hack room just now for writing more benchmarks. We feel industry benchmarks aren't necessarily very good for the level of examination that we're going to have to do when making ART quicker. Also, if we've got other assignees into Linaro, it would be very good to be able to generate benchmarks consistently. So we'll depend on infrastructure there. And as well as all of that, we're going to have to monitor the upstream efforts of AOSP. So having our benchmarks running regularly against the tip means that when there's changes upstream, we will be aware of the effects of that and maybe mitigate or help improve it. So today, we've got things running for builds. We've got some tests running. We're not quite there with benchmarks yet. But assuming all of that comes through, which it is, there's Vishal and Milosh working on that in the team. Where we want to take this in the future is actually to do more optimizations. So just now we're keeping up with TIP. And part of the reason is we want to also have two types of optimization. So we've got small optimizations, little tweaks here and there, which don't necessarily take a lot of time, and then have more ambitious optimizations. So colleague Ninsheng here has been working on things like instruction scheduling, which does take a lot of work and a lot of investigation over many weeks to do. And another thing to watch is that we are also having to be competing against other architectures. So we will have to try and do these optimizations to try and catch up. Testing is very important. Don't know how many people have worked on compilers, but they can have interesting behaviors and interactions within themselves, so testing is very important. And ultimately, if we get more, what I would really like is for there to be Linaro assignees into our team. And so having more people means that as well as working on the compiler backend, we can also concentrate on things like GC and threading, optimizing for big. LITTLE, and all the other parts of the runtime. So Linaro assignees will help us to do that, and we'll be able to do more and better together. So that was very quick. Are there any questions, queries? Sherban, the plant.
How can I meet and help the Linaro art?
How can you help and meet the Linaro art team? That's a very good question, Sherban. So we're in the LMG hack room. Come along, say hello. We're on #Linaro-art if you want to join us. Talk to Scott if you want to help as well with the micro benchmarks. We'll be very kind. I've put a URL in the subject for #Linaro-art to take you to the information there.
Check out the slides, and there are some fun benchmarks to write. Ray tracers, Amiga Stokes, encryption, things like this. It'll be fun.
Well, I'm convinced. Any other questions? No? Silence? Okay.
All right, thanks, Stuart. Okay, next up is AOSP kernel upstreaming status, and so Samit, you're next.
So, thanks, Tom. I'm Sumit. I lead a small team inside LMG for the kernel work, and we have John, Amit, Sam, and Jochen on the team. So I am just going to give a short, quick overview of what we've been doing since last Connect and where things have been. So when it comes to kernel upstreaming, we have been working on USB Gadget FS work where we have tried to help Android move over from their own implementation for using composite gadgets to the mainline Gadget FS drivers, and there's been really great collaboration with Android engineers. Amit will talk a lot more about it in his presentation. So I'm just going to give very, very short intros about things. The RFC has been posted upstream. There's been very good constructive comments that we've received, and Amit is working very well on it. We've heard already about the Android PPP drivers from Sam. So the whole idea of saying upstream Android PPP drivers was not really to say which implementation is better, but to probably see what fits both the use cases, and that's what Sam has been really good working on. Then there is this initiative from John where we are trying to have Nexus devices work with latest mainline kernels, and the whole idea is that it should enable us to fix and find and fix issues with merging mainline things much sooner than it is possible with AOSP. Right now, we are dependent on using AOSP kernels, which could be as old as maybe few years. So there's been good progress on it, and again, John has a full-fledged presentation about it. I think tomorrow, Thursday. So then there's been some work that I've been doing on ION. We sort of proposed a solution or something that was like a solution for upstreaming ION features, but it sort of got rejected amongst many of the upstream guys. But the good thing is that now there is a good amount of consensus on how we can get ION out of staging and into mainline, and that's probably going to be very useful for getting our code deficit, code delta to reduce as much as we can. We are still continuing to work on various other myriad things, like there are C group patches that John has been working on. There are a few networking things, USB wake-up source, and we have a list of things. So yeah, that's what we've been doing. In addition to the stuff that is directed towards upstream kernels, we also have things that are directed towards AOSP. So we have, thanks to the collaboration that and the relationship that we've begun to have with the Google engineers, there is a lot more increase in the contributions that we make to ASPs, and that also is primarily due to the effort of John and Amit on creating the Linaro fixes branches that we have, and these branches then get included into LSK as well. We did an audit of, we've had this sort of habit of doing an audit of whatever is the latest AOSP kernel. So we did the 3.14 and 3.18 audit to figure out if there are any new features that the Google guys have added into their kernels, and also to figure out if there are some remnants of old patches which are not useful anymore. And so thanks to work done by one of our ex-assignees from TI, Gregory, we were able to share a list of patches that are no longer necessary, and we shared that with Google, and it was fairly well received by them. On the LSK branch management side, we have branches which are regularly updated, and fixes are provided as required. And in many cases, these fixes then feed back into ASP, so the delta becomes as short as possible. We have created a 4.1 preview branch, even though there's no ASP 4.1 yet. And the idea is that it should provide value to our members who have an intention of using 4.1 for any products. 3.14 LSK is in maintenance, and we have 3.18 as the current active monitoring branch. So yeah, that's all I had. Thanks. And
FIQ work from Daniel still going on.
oh, I'm sorry. Yes.
Yeah. One of the items that got skipped over there was Daniel Thompson's still been continuing work on the FIQ work, even though he's moved out of LMG and is doing other work, but he's still kind of in his spare time still doing that. So I wanted to make sure he got called out.
Yes. Yeah, I'm sorry, I missed that one out. So yeah, any questions or comments on?
For the PPP driver, you just mentioned the PPP driver and the USB gadget FS, this driver. Are these features also in LSK 3.10 Android branch?
Yeah, so these are features which are there in Android branches. So PPP is already working in Android, but we are trying to see if we can use the mainline implementation of PPP to work with the Android case.
Did you mean PTP?
Yeah.
Okay, he's talking PTP now. Sorry. So yeah, I think Amit's talk on this. Yeah, I'll let you.
Yeah, hi. So AOSP kernel does have MTP and PTP working. So
With config.fs.
with config.fs, yes, with config.fs. The legacy Android gadget doesn't work. So you have to use config.fs based implementation to get MTP and PTP working.
I think that's 318 and above, right?
318 and above, yes. I think
your question was for 3 or 10, right?
My question also, are these drivers in the 3.10 LSK branch?
no, no. 3.10 still uses Android composite gadget driver. It doesn't use config.fs based thing. So, okay, so you can use composite gadget driver as such. No, 3.10. No.
That's the first time it got merged was in 310, and so it was still a little rough, I think, and I'm not sure if it would quite be suitable for use. But there is config.fs gadget support in 310. It's just I'm not sure how viable it really is.
In AOSP kernel 3.10.
So in the AOSP 310, there is the config.fs gadget again. It was merged upstream in 310. So it is in the AOSP one, but they're not using it. They're still using the Android composite driver, gadget driver. And I recommend to use that for the 310 trees.
Another question. Yeah. If the I1 is auto stage, if the I1 is auto stage, what's the instead? To instead the I1.
So it will move out of staging into mainline. That's the idea. Right now, Ion framework and drivers are in staging in mainline kernel.
Yeah.
So moving out of staging would mean that if we can, we will move it out of staging and into its own mainline as a mainline kernel driver.
Thank you, Smeet. Thanks, John. Thanks, Emmett. Next, we've got Gil Pitney from the GPGPU team to talk about Shamrock and version 1.2.
Okay, thank you. Yeah, so this is going to give a little update on some of the work we've been doing with Shamrock, which is an OpenCL driver for the ARM. This is work that we've done with Shogu, also is in the GPGPU team, and Tom and other people have helped along the way. So just a quick refresher, OpenCL, I think most people have an idea of it, but the idea is that you define, it's for offloading computation to typically accelerators like GPGPU or DSP. In the case of Shamrock, it's offloading computation to multiple ARM cores. So you define, say you have, in this case we have a matrix multiplication. You define an n-dimensional computation domain. In this case, it's one-dimensional. You execute the kernel at each point in the computation domain. So on the left side is a traditional loop in C, where we're multiplying the columns of the matrices, A and B, to get the result C, the vector C. In OpenCL, which is a version of C from the Chronos standard, defined by the Chronos standard. This is the kernel, which is offloaded onto typically an accelerator. The kernel bit of code here runs at each point in the computational domain. In this case, each point along the one-dimensional line. The function getGlobalID is a built-in function of OpenCL, which will get for dimension 0, so that's the first dimension, the index into the n-dimensional computational domain, or the index into the line, the vector. And so it implements this, it runs this kernel at each point in the space, in the output space. And OpenCL driver takes care of dispatching that to the right number of cores, the right number of accelerators depending on how you set up the number of work groups and work items per work group. So that's what OpenCL is. Shamrock is an OpenCL driver. It's a CPU only driver right now for the ARM. It's based on the TI OpenCL, which is based on Clover. Clover was a OpenCL driver written, it's a Google Summer of Code project written by Dennis Stickelmacher, if I pronounce it right. TI added the DSP device because TI is really into DSPs. And that currently ships with the Keystone 2 MCSDK for high performance computing customers. So one of the Moonshot, HP Moonshot clusters is based on the Keystone 2 device, which is ARM plus multiple DSP cores, C6XX DSP cores. Linaro took that and updated it to work on ARM. We needed to move from JIT to MCJIT to support ARM as a compute device. We've been validating this with Piglet and the Kronos OpenCL conformance tests. And recently we've been updating Shamrock to version 1.2 of the spec. So 1.0 of the spec was implemented, 1.1, and so we've been doing 1.2. They're both available open source software on these links. The TI OpenCL at the git.ti.com, GitHub, Git repository, and we're in Git Linaro. So some of the features in 1.2 that have been added, before you had to compile an OpenCL program in one big step from all source or binary. Now, it's an obvious addition, but it didn't exist before. Now you can create libraries of compiled OpenCL functions and then link multiple libraries. It's a good move forward. Libraries can also be embedded, include headers. So you can take an include file, call it a library, make it into a library, and then link it in with other programs. There's a new built-in called printf, which if you ever debugged an OpenCL kernel, it can be difficult depending on the debugger. Even in GDB, it's a little difficult to get source level debugging for the kernels. Typically, you can debug in assembly, but it's nice to have printf to sprinkle in your code as a fallback. Various API updates, they've deprecated some APIs, merged some others. They've added a new API to initialize buffers. Previously, when you created a buffer, it had to be initialized on the host or a special kernel. Now there's a API to do that automatically. One of the big features of OpenCL version 1.2 is something called device fission. And so previously, when you got a device, when you opened up the platform and queried the devices, you would get a device. If you had a multiple core platform, a device that would cover all the cores on that platform. Now you have an API that allows you to partition all those cores into separate sub-devices, and then you can, for each sub-device, create a context, a work queue, and a program for that particular group of cores, and you can manage the assignment of work to each of those subgroups. So it just gives the user more control over parallelizing the work. You could also, in theory, reserve some of the cores for high priority compute tasks and let some of the other cores be used by other kinds of system functions, so that you can reserve part for OpenCL and the other part for other software. So that's a good feature. So some of the next steps, I'm currently looking into adding installable client loader support. What that allows you to do is then, if you have an OpenCL driver that's enabled for ICD loading, you can have multiple OpenCL drivers working side by side. So you could have say the TI OpenCL driver that's talking to the DSPs, running simultaneously with an AMD OpenCL driver offloading kernels to GPU, and that can be done from the same application. Of course, they're different kernels because they compile to different ISAs, but you can have these running simultaneously. So that's a good feature that's going to be added. And then the last thing that we're looking at now is, so given this, the acceleration of open source projects with OpenCL. We might hear tomorrow from Neil Trevette that Vulkan's coming along. Vulkan is a new Chronos standard which combines graphics and compute. They have a new intermediate representation called Spear V, which has some compute APIs, compute concepts thrown in. And so we'll be looking at Vulkan as well to see if we want to accelerate projects with Vulkan once Vulkan becomes real. So that's it.
All right, thanks, Gil. And next we'll hear about our hardware composer efforts. So, Zinlan, do you have VGA? Okay. Okay.
You've shared it with me as well?
Oh, okay. The link to your slides. Yeah, so I don't have anything from you. Do you know the name of the document is? So. Half a moment. Use your laptop to hit the share button. So yeah, bring your laptop up. Got it. I have it. It's actually shared. So you're on it instead? Yeah. Okay.
So it's just wait for a minute. Okay. Today I want to talk about the KMS hwcomposer to you. And my name is Xin Liu, and I as a new from the Hyatt Silicon company. So this is the content I want to show you. And first of all, I want to explain what's the KMS hwcomposer and the goals and the software architecture and the implementation status. It's about the progress we have done and what's to be done, and also the relevant work, and at last some useful links. So what's KMS hwcomposer? KMS is known as the kernel mode setting of DRM driver. And the hwcomposer is a user driver similar to the Windows video driver, which handling more and play setting. And it is a different one from the FB device-based one. So what's the goal? Our goal is create a common reference implementation of the KMS hwcomposer for multiple SoCs. That is, we want to replace the Regency FB device-based hwcomposer. Usually, the hwcomposer implement by the FB with the FB device use the private I/O controls. So we want to unify the Linux display driver backend for both PC and terminal device. And secondly, we also want to implement well and use the common codes so that the vendors can reduce the effort to support a new SoC. And last, want to allow to use the hardware composition. That is also called the overlays, compatibilities. So this is the software architecture. And on the top is the service finger of Android. And then the hell layer. So as you can see, hwcomposer stay in the hell layer. And next is the kernel DRM driver. And the geolog module is for flavor locking, and usually using the ION or the DUN or some private interface, and the KMS is required. And for the kernel DRM driver, the KMS feature and play may be required, and the play is also no. If no play DRM play, then it will fall back to the GPU composition. That is to say, GPU will do the composition. So this is the architecture of the hwcomposer. So as you can see in the hell layer, hwcomposer module will interact with the libDRM, and the libDRM interact with the kernel DRM driver. So about the implementation data, this is the things that we have done. Totally, this is the basic function. That is the more and play setting and multiple display support, primarily and external, such as HDMI interface, and also the hardware vSync. It is known as the read-blank handling, and the fence and the cursor layer. And the two boards we have a support now. STI boards with STI H4 series SoC and the high keyboard. Actually, my work is based on Benjamin's. Do you know Benjamin? Benjamin's work. Benjamin support the STI boards first, and then I support the iKey board. So these are things, a lot of things to be done. The most important, I think, is the ultimate mode setting. This is a new thing. And also the alpha blending and the layer or the play rotation. And also the support the hot plug. And also the virtual display, such as a Wi-Fi display, and some other performance optimization. x86, they also have open source KMS hwcomposer, and it is belong to the x86 Android project. And it concerns with concerning about the DRM, Shamrock, and the Intel hwcomposer. This is the two repositories of the x86 Android project. So we make a comparison with x86 KM Composer. And sure, they focus on x86 platforms, and Linaro is focused on ARM SoCs. And their hwcomposer module is very simple because most of the work, such as the play and mode setting, are all handled in the Shamrock module. And therefore, our hwcomposer handle the play and mode setting inside the hwcomposer. And they now support only hwcomposer version 0.1, and ours may support version 1.1, but the latest version of hwcomposer of Google is 1.4. So this is maybe the useful links about the wiki and all the open source code address. So that's it. Thank you. Any questions about this part?
One, I was curious. I saw you said that the fences were done, and I saw that fences were done in this slide, and I was just curious kind of how and kind of what the status of that was, as far as I know there's still some work to be done.
Fence, right? We now handle a fence in a hwcomposer inside it, and for which each layer we have a fence to handle.
Does DRM export fence points?
Fence, yeah.
It does.
Yeah,
Okay, that's new.
thank you.
All right, well, if there aren't any other questions, that's the end of the session. So I want to thank everyone for coming, and thanks again to all the speakers for the session.